Hello and welcome to Database Management Systems. I'm Juvita Christie, and in this video, I'm going to explain to you the first normal form, the process of normalization, and decomposition.
So what is normalization? Normalization is the process of decomposition of relations to reduce redundancies and anomalies in the database. So redundancies mean a lot of duplication of data. So you might be storing some data unnecessarily several times, and that leads to redundancies. And redundancies cause problems which are called anomalies. And anomalies are basically problems in the database where you are not able to update the database or delete values from the database properly because of the lot of duplication that is happening in the database. And decomposition is where you cut or you break one table into many parts in order to perform normalization. So normalization is done using decomposition. Now normalization has several steps. The first step is 1NF, which is known as the first normal form. Then the next step is 2NF, which is known as the second normal form. Then we have 3NF. 3NF stands for third normal form. And then we have BCNF. BCNF is the Boyce Codd normal form. And then we have 4NF, which is the fourth normal form. And finally 5NF, which is the fifth normal form. So these are the several steps in normalization, and you cannot reach one step without going through the others. So that means in order to reach 5NF, you have to first go through 1NF through 4NF, and only then you can reach 5NF. Now let's see 1NF in a little bit detail. So 1NF stands for the first normal form, and the rule here is that all domains should be atomic. So atomicity means you have domains which contain only one possible value. So it should not happen that you have domains that are non-atomic. For example, phone number. A person could have several phone numbers, and these phone numbers always have to be stored in separate rows. If they are stored together in the same row for each person, then that column becomes non-atomic. For example, you can see here there is a table. So this table contains three columns: group, topic, and name of a student. There are two groups, group A and group B, and the topics are DB and MySQL. And you can see that in the student column, there are two students mentioned, John and Mark. So John and Mark both are studying DB. And Luke and Matthew both are studying MySQL, which is in group B. Now here, the column student is an example of a non-atomic domain because, like I said, you cannot store two values in the same column just by putting a comma in between. Then your database is not in the first normal form, which is the first step of the normalization process. So in order to remedy this, we would have to do something like this. So what we've basically done is converted this table with just two rows in it into a table with 4 rows. And now this table contains John, Mark, Luke, and Matthew separately in each row. And you might notice that there is some duplication of data. For example, group A is coming twice and group B is coming twice, and then DB and MySQL are also coming twice. But that's all right. We are going to deal with all that a little bit later on. But for now, this is okay. This is our first step in the normalization process. Now, let's move on to the second step in the normalization process, which is called 2NF. 2NF stands for the second normal form. And here the condition is that your relation should already be in the first normal form. That means your entire database should already be in the first normal form. And then there's a second condition that says there should be no partial dependencies. And the meaning of partial dependencies is what I'm going to tell you right now. Now, at this point, you need to know what are functional dependencies. Okay, so if you haven't yet studied functional dependencies, I'd recommend that you go ahead and watch the video on functional dependencies that I have linked down below in the description box. And if you just need a quick revision also, I would expect you to go there, because only then you'll be able to understand this video properly. So you have no partial dependencies. So first you need to understand what partial dependency is. Now consider this table. This table contains course ID, semester, total number of students, and the name of course, right? So there is a course ID given. Each course is having a unique ID, and there's a semester for each course, and there are total number of students given taking that particular course, and then the name of the course is given. And in this case, I'll mention the functional dependencies present here. So the functional dependencies present here are course ID determines course, and then course ID and semester both together determine total number of students and course. So here I'd like you to notice first of all what a functional dependency does. So when I say course ID determines course, then you can see from the table directly that if I ask you which course has the ID 101, then you'll definitely tell me that it is DB. Because from the table you can see that 101 is coming 2 times, and both the times you are having DB as the course. Then you have 102, and 102, if I ask you what is the course, then you are going to tell me that the course is SQL, because 102 is again coming only once, and it's coming with SQL. And if I ask you what is 103, then you'll tell me it is CN. So this is all very simple. You can directly tell me from the course ID which course it is. Right. But there's also another type of functional dependency created here, and that is where I've written course ID, semester determines total students, course. So this dependency is where if I give you the ID of a course and the semester together, then you can tell me how many total students are taking that course, and at the same time you can tell me which exact course it is. So this is now a partial dependency where you see that course depends on course ID as well as semester both together, but at the same time course can be determined by itself just by looking at the course ID. So in this case, we would have to do something called a decomposition. Now this is a problem in the relation, and I'm going to tell you why it's a problem in a little bit. But first we have to learn what decomposition is. Decomposition is where you break one relation into several relations in order to make the database better and more efficient. So we're going to see what is decomposition first. So consider this table. It contains S#, status, and city. S# here stands for the supplier number, and there's some status given about how many parts are there and how many are left. So this is a small table that I have taken from an auto parts database. Okay, and this table simply shows the number, the supplier ID, and the status of that supplier, and the city in which that supplier functions. Okay. So it's a very small table, only 2 rows, contains S# and status and city, 3 different columns. And now I'm going to show you what can be done to this particular table, how you can break it into 2 parts. So the first part is you can make it S# and status, and the second part you make is status and city. This is one possibility of doing it. So you can see I've not done much. I've only separated this table of 3 columns into 2 tables, and each one contains 2 columns. the reason why you have to keep two columns, you cannot make a table with one column because it would be just useless, So there's no point in making a table with one column, although in some cases you might want to, but in this case we wouldn't want to, because after we separate the table, we should also be able to combine it once again. And to combine tables, if you have studied SQL, you would know that you would need primary keys and foreign keys in order to perform a natural join. And so for a natural join, you require some common column, and that's why the column status here is common between the two tables. Now the second possibility is S hash and status, and the second part of the table might contain S hash and city. So these are the two possibilities, and we are going to see the meaning behind these possibilities. So let us first see the first possibility, that is S hash status and status city tables. So in this case, let us take a natural join of these two. Okay, so what happens when you do that? This is what you get. You can see that my table now contains 4 rows, and the reason for that is S3 is having a status 30, and the status 30 matches with the 30 that is coming twice in the right hand side table. And the same way S5 is having a status 30 also, and this also matches with both the rows on the right side, and that is why I am getting 4 rows. And what was my original table? It looked like this. So you see, after decomposing the table into these two parts, I am unable to get my original table back. So you can see here that my original table is lost, and when I say that there is a loss of data, that doesn't mean that the original rows are gone. The original rows are still present, as you can see, but you can also see that there are also some extra rows. There are 2 extra rows. Now when I look at the table, I have no way of telling which rows are from the original table and which rows are not from the original table. So because I cannot tell the reason behind this, I'm saying that the data is actually lost, and that is why this is known as lossy decomposition. And this type of decomposition is not good. So let's review the second type of decomposition that we saw, the second possibility, where we are using S hash and status and S hash and city. And let's see how this works out. So once again, we are going to take a natural join for these two. And when you take a natural join for these two, what you get as a result is this, which is actually our original table. And you can see why we are getting this, because here the common column between the two tables is S hash and not status. So when you look at the tables, you can see that S3 is coming only once on the right hand side table, and that is why it produces only 1 row. And S5 is also coming only once on the right hand side table, and that is why this also produces only 1 row. So what you get as a result is a table that is the original table itself. And so this gives us a lossless decomposition. So that means there are 2 types of decomposition. So one is a lossy one and one is a lossless one. And obviously, if you are performing a decomposition for your tables, you would want to do a lossless decomposition and not a lossy decomposition. So for the normal forms that we are going to study from now onwards, that is from 2NF to 5NF, it is necessary to understand the difference between a lossy decomposition and a lossless decomposition. So what exactly is it? What exactly is a lossy decomposition and a lossless decomposition? And why one decomposition is lossy and one is lossless? There is a reason behind that. So if you look at the table, you'll notice that status is in no way a primary key. Would you call status a primary key? No, because status contains 30, which is coming twice, and both the times you can see that it is coming with different values. So you cannot say that status could be a determinant in a functional dependency. So status cannot give you the S hash or the city, because whenever you look at status and I ask you, okay, the status is 30, now you tell me which city that belongs to. You have no answer because it belongs to Paris as well as Athens. So I cannot answer that question. And that is why we cannot use status as a primary key. So as you can see in the lossy decomposition, status is being used almost as a primary key foreign key relationship. And because it is not unique in either of the tables, it is causing this problem of lossy decomposition. So this means you must never decompose based on a column that's not a primary key and based on a column that does not determine the rest of the columns, which in other words is a primary key. Now in the lossless decomposition part, you can see that I've used S hash, and S hash is unique, and that is why it is also the primary key of the table. And if you look at S hash, if I give you an S number like S3 or S5, you can uniquely determine the other columns, the values in other columns of that particular row, because S3 and S5 are both unique and they are not repeating in this table. And so when you split the table using S hash as a reference, then it gives you a lossless decomposition. So this is where I'm going to end this video on 1NF and decomposition, and that does not mean normalization is over, of course. Like I showed earlier, normalization has many steps, and we've only just begun. We've only just begun to understand it by learning 1NF. To understand the rest of the things, you need to know what decomposition is. So now we are going to move further and understand 2NF and 3NF, and for that this will be continued in the next video.